So part 2 of using trigonometric identities is actually prove. So I'll share the first one is prove that 1 take away tan theta times sin theta times cos theta is equal to cos square of theta. So how can we actually prove that? So we've got an identity. What does an identity mean? Identity means that we cannot move from right to left. So we need to stay on one side. So on the left hand side even, we're going to have 1 take away sin theta over cos theta times sin theta over cos theta. How do we get that? Well, we know that tan theta is actually sin theta over cos theta. So what could we possibly do here? Well, these two can cancel each other out. So you're simply left with sin square of theta. Now, what else can we actually use here? Because it says I want to go from 1 take away sin squared theta into cos square of theta. Well, we can use this one down here. Sin squared of theta plus sin plus cos even squared of theta is equal to 1. So therefore, 1 take away sin squared of theta must be equal to cos squared of theta. And hence, this is how you'd actually prove this. So, whenever you've actually got tan theta, I would suggest changing it into sin over cos. Okay, so let's say the first one is sin theta over cos theta plus 1 over sin theta over cos theta. Now, this one here can be simplified, so it's 1 over sin theta over cos theta. That can be simplified into, or is equal to, cos theta over sin theta. So hence, this is why they've got that there. So by adding them, so I'm going to make the same denominator. You're left with, multiply this by sin theta, and this is by cos theta. So you're left with sin theta plus cos theta squared, all over sin theta plus cos theta. So what is sin squared theta plus cos squared theta? Well, it's equal to 1, so therefore that's us proving it. So if anyone's actually thinking again here, how did I go from that here to this? Well, in theory, what I want you to be thinking is 1 divided by sin theta over cos theta. How do you divide the fractions? When it's 1 times cos theta over sin theta, hence cos theta over sin theta. Okay, keep flip chains. So pause the video for us and try these two. So for the first one, you should have, again, straight away, they've changed it to sin over cos. They've changed the 1 take away cos squared into sin squared x. And these cancel each other. The square root and the square cancel each other. So you're left with sin x over sin x, which is equal to 1. Same again, prove that tan squared of theta equals to 1 over cos squared of theta, take 1. So right hand side, break it down to sin squared theta over cos squared theta, 1 take away cos over cos, and then simply break it down. Okay, this is a bit backwards, but that's the way you would do it. So your exercise for today are these for us. You need to prove these questions, and you need to make sure you do these ones. So pause the video, mark your work, so you'll frequently encounter, so obviously there's no solutions here. If you need any help with these questions, okay, please make sure you message myself or Miss in order to get the answers for it. Obviously, if you get to one side to the other, this is how you would do it. So you'll frequently encounter angles 30, 60, and 45 in geometric problems, okay? Why? We see these angles in equilateral triangles, a right angle, isosceles triangles. You need to be able to calculate these in non-calculated exams. All you need to remember is draw half a unit square and half an equilateral triangle of side 2. And then you're pretty much able to actually work these out. Square root 2, why is that? Of Pythagoras. And therefore you're able to work out the rest of them for us. Now remember, for these ones you probably see it like that. Okay, because of actually rationalised denominator. Same again for sin 30. So exactly what you've done pretty much the last lesson. For 0 to 90, just think about the graphs of trig functions. Given that sin theta is 3/5 and theta is the acute angle, find the exact value. Well, if I had to represent a triangle, what would that triangle look like? So this is the acute angle, say, for us. Sin, opposite of a hypotenuse. So that means the hypotenuse is 5 and the opposite must be 3. So we need to find what the other one would actually be. So simple like that. We work out that the missing one is actually 4. So therefore, using Pythagoras, obviously, you can work out. So 4/5 and 3/4. So given that cos theta is 5/13, and that theta is an acute angle, find the value of sin theta. What should it be? It's 12/13 and 12/5. So again, pause the video and try these two. √5/3 and 2/3.